got a few more questions to work through. So 1A, I would first up divide this up so it ends up looking like a rectangle. So just imagine that was a straight line, just like the dotted one is. And we end up having a rectangle, this shape in the middle, which is 4 meters across, 3 meters up. 4 times 3 is 12 meters squared. Now we've got to factor in the triangles. Now because we've got 4 meters at the top, we've got 6 meters here, which means we've got 2 meters left over. It actually doesn't matter how you end up splitting the 2 meters, just as long as they're accounted for. So if you had one here and one there, or half and then 1.5, it wouldn't make a difference. As long as you've got 2 meters as your base in total. We would just use for triangles half base times height, and half of 1 is a half. Then multiply that by the height of 3. That ends up getting you 1.5, and that's 1.5 for each triangle. 1.5 in this triangle, 1.5 in the other. That's 3. 3 plus 12. End up getting an answer of 15 meters squared. For B, same sort of deal. We draw a line here. That way we get our rectangle, which is 12 by 10. 12 times 10 is 120 centimeters squared. You will have 6 centimeters left over because 18 times take 12 be 6. So again, it doesn't matter whether you do 3 here, 3 there, 4 or 2, as long as it's 6 in total. I'm just going to keep it even and go 3. So you're going to do half base times height. The base will be 3. Half of 3 is 1.5. 1.5 times 10 is 15. So that one's going to be 15 centimeters squared. That one's going to be 15 centimeters squared. 15 and 15 is 30 plus 120. Add that up, you end up getting 150 centimeters squared. For C, again, we're just going to draw a line to get our rectangle and triangle. It's 65 up, it's 72 across. If you do 65 times 72, you get 4680. So that's millimeters squared. That's my rectangle. And for my triangle, half base times height. The base is going to be 98 takes 72, because there's 72 here. That means you've got to have the remaining 26 here. Okay? So you're just going to do half times 26 times by the height, which is going to be 65. And then you're going to get 845, which is the area of this shape. And then you add up your 845 plus your 4680, and you will get 5525 millimeters squared. Okay, now we're looking at 2A, calculate the area of the following sectors. Like we have looked at before, but I mentioned it anyways, you'd normally use all 360 degrees when you're trying to calculate something all the way around. Sorry about my dodgy circle. But because we're only looking at 32 degrees, instead of using the normal pi r squared, we're going to use 32 out of 360 times the pi r squared. And the r radius is 6 meters. It's going to be pi times 6 squared. You multiply that all out in your calculator, and you should get times pi times 6 squared. You should get 10.053, which I'm just going to leave as 10.05. 10.05 meters squared. Then the next one is going to be the same sort of deal, but we're using 16 as our angle because there's a very small angle there of 16 degrees. So 16 over 360 times pi times 298 squared. Should get a pretty big number because we've got pretty big units there. Well, it could be a big number because the 298 squared is a very big number. Times 298 squared Yep, 12,399.377, which I'm going to round up to 38. 12,399.38 millimeters squared. Oof. I'll write that slightly neater. Millimeters squared. And now for C, same as what we've done before, you've got to have the angle out of 360. Then times pi r squared times pi times 2.7 squared. 2.7 squared with my 215 over 360 and pi, and you should end up getting 13.677 kilometers squared, which I'm going to round up to 13.68 kilometers squared. So that's how you do those. Hopefully it was all good. Leave any comments if you've got any queries about anything.